Welcome to the another interesting part of the knowledge engineering. So, wherein we look upon the two familiar things, but in uh, not taken in a proper or in a scripted manner, right? So that is the technique so called the forward and backward reasoning, which are the two fundamental approaches used in the inference and the problem solving in the logic based systems such as expert systems and the knowledge based systems, right? So first let us discuss about the forward reasoning. So the forward reasoning in definition is also referred to forward chaining, is a bottom-up approach to inference, to infer where the conclusions are derived from the known facts by applying the inference rule until no further conclusions can be drawn, right? So basically, this process starts with the known facts or the initial data, and with that facts or the initial data, we apply some rules, and we come to a new set of facts or the conclusions, and this will be repeated until further there is no other investigation or no other claim can be done on it. Let us say, for an example, a treating for a disease. Okay, so we start with the initial symptoms. So if I'm going to doctor, I'm expressing my in discomfort and symptoms to him. So what he and do basically is based on the symptoms, whatever I say, he will try to figure out what my problem is, and either it may be exact or it may be an approximate. No other what to say that no conclusion will be arrived at until otherwise there is no further question. So let us say, for an example, I'm let's say consulting a doctor. I'm just stating him I have a temperature and I have the feel of nausea, and then I'm not able to take food. Okay, so initially he will test for the temperature, then he will give some medicine. He will perform the preliminary check, right? The medicine will be prescribed after performing the preliminary check like heartbeat, pulse rate, and then they'll check the BP, they'll check the saturation level, and he will ask further for any other discomfort or symptoms, whatever I may face. So he will have a set of questionnaires put to me, right, to arrive at some conclusion. Okay, so based on the response whatever I provide, so he can come to an initial guess and he will prescribe some basic medicines, the initial medicines. Okay, he may advise some paracetamol for 3 days, then he will ask for just take this medicine. You whenever suppose you check whether the temperature is still increasing or not. If it is still increasing or if it is repeating, then we can go for further testing. Okay, again if I go for third day, again I'm telling that the severes or some other symptoms are already the existing symptoms getting worsen, then immediately he will prescribe for a blood test. So based on the blood test results, again he will go for revising the medication, right? Okay, so you see, the initial medicines were provided based on some facts and figures whatever we say, and matching with whatever the knowledge that is present in his database, right? So case by case they will rule out. Initial, the very initial step itself, they will not ask you to take a numerous blood test, and then they will go for scan x-ray, these that and all, right? They will try to eliminate the causes one by one. They'll because they'll understand they'll able to estimate the stable conditions. Okay, if the patient is stable, okay, then we can proceed slowly. If the patient is not stable, then the degree of treatment will differ. So this is the fact that will happen in a general scenario. So here how it starts, they are taking up some initial action based on certain information. They are arriving at some conclusion. They are taking up the corrective action for that. Then still further the problem persists. Then they are narrowing down the reasons, and finally they come to a conclusion and the diagnosis on your health. So further there is there will not no more queries that will arise on the on your medication, right? So this is an example of the forward reasoning what we consider here, right? So you can see this, the example what we consider is in a medical diagnosis system. If a patient presents the symptoms A, B, and C, and the system knows that patients with symptoms A and B will have disease X, it can infer that the patient likely has a disease X, right? So the advantages here is it is efficient for the systems with a large amount of data but relatively few queries, and it can efficiently explore the space of possible conclusions and hypotheses, right? And this is commonly used in the systems where the goal is to derive a specific outcomes or conclusions based on the available data and the rules. And it is particularly useful in the rule-based systems or expert systems and decision support systems where the focus is on generating the predictions, recommendations, or the solution, right? So in this example, in a diagnostic for expert system for the medical diagnosis, the forward reasoning starts with the observed symptoms and applies rules to infer potential diseases or the condition. Okay. In the backward reasoning, this is an top-down approach, which is completely the ulta of the forward reasoning. So where the initial diagnosis or the basic knowledge will not be sufficient to arrive at some conclusion. So what we do is we do in the reverse process here. Okay, the reverse engineering, whatever we say here, right? For an exam, okay, the same medical field, you just taken expert system, right? I have uh, I have some swelling or a kind of bulge on my hand, okay, and it is there for quite long time, say 2 months or 6 months or even a year or more, right? So initially I'm not facing any pain on it. If I touch it, if I push it, no, I'm not facing any pain. Maybe after some time it may develop some sort of pain or discomfort for me. So upon that I'll go for, I can go to doctor and they can tell me what are all the scenario, the history behind that swelling. Okay. So he will do an initial examination. He will touch. He will feel how that swelling is there and what where it originates by just by an a simple physical examination. Further, if he has some suspect, then he may ask me to go for an X-ray or an MRI or a CT scan, depending on the location and depending on the type of them. Then he will go for with the results of your CT or X-ray or whatever the type of scans, he may suggest a surgery. But again, till then, there is no diagnosis that is being made on this swelling, right? So what they will do, they will take some tissue. That tissue will be sent for testing, and after the results of test has been arrived, then only you will be provided with the appropriate medication, the diagnosis followed by the medication. So this is an example of a backward reasoning or the reverse engineering what we consider here. So, in this backward reasoning, the process starts with the goal or query that needs to be satisfied. So, I have a lump or I have a swelling which needs to be diagnosed, which needs to be treated. So, I will keep on doing some iterations to arrive at until I get a proper, my results are matching with the one what I had in my initial case or my goal, right? So we use inference rules to derive the conditions or facts required to satisfy the goal, and this process is repeated recursively until reaching known facts or assumption. Okay, so again here you see this an expert system. It is meant for troubleshooting, where the goal is to determine the cause of a malfunctioning of a device. Let us say I have a remote which is not working. So what I do, I'll try to replace the battery. Even after replacing the battery, if it is not working, I'll try to save, suppose because of, is there any liquid spill from the previous battery or any other condition, I just go on in a reverse way, right? Basically what all we know is to replace the battery and to check for whether any moisture is present or not. Okay, and then we'll move on to this. See, we are not developing the remote, but already there is a remote control which has undergone some failure. So we are changing the case to case until the remote starts functioning, or we come to a conclusion the remote will not function anymore, or the problem cannot be fixed. Then we need to go for the new one. And the advantages of this backward reasoning is it is efficient for the system where the goal is well defined, but the data or knowledge is complex. So it focuses reasoning efforts on the relevant information needed to answer specific queries or achieve goals. And it is commonly used in the systems where the focus is on the problem solving or the goal directed reasoning, and it is particularly useful in planning systems, diagnostic systems, and troubleshooting application where the goal is to determine the actions or steps need to achieve a specific outcome. Okay, and just taken an example in a planning system for scheduling tasks. The backward reasoning starts with the goal of completing a task and determines the prerequisites or subtasks that is required to accomplish it. Okay, and this is a general example, a very generalized example which can be applied in multi-domain. So if we compare this forward reasoning and backward reasoning, so the forward reasoning is more suitable for the systems with a large amount of data and relatively few queries, whereas for the backward reasoning system is suitable for the systems where the goal or query is well defined, but the data or knowledge is complex. Okay, and the forward reasoning explores the space for possible conclusions in the bottom-up approach, while the backward reasoning starts with the desired conclusion and works backwards to find the necessary conditions or the facts. In terms of efficiency, forward reasoning can be more efficient when exploring a large knowledge base, while the backward reasoning can be more efficient when focusing on the specific goals or queries. Okay. So far, we were discussing about how we can represent the knowledge in the domain where we have a sufficient information that can be put on. Okay, so now let us discuss about how we can represent the knowledge in an uncertain domain. Means, let us say I'm making, just you take I want to arrange the cards in the form of a pyramid, or just I'm making it. Okay, I don't know at what level it may fill down. That is uncertain, right? Okay, I am arranging the cards, okay, the playing cards in the form of a pyramid. I don't know I need to, I am just starting from the level 7, and I need to reach the level that is level 1 with 7 cones, 7 triangles, and I need to continue this till the top, the level 7 where I will have a single triangle. I don't know at what condition it may fall or it may not fall. So now under these conditions, right? So these are uncertain, right? So under these uncertain conditions, how an expert system will work effectively, or in what are all the steps that we need to make it to develop an AI based system to take some decisions in under certain uncertain conditions. Okay, so the representing your knowledge in the uncertain domains involves the handling situations where the information may be incomplete or imprecise or uncertain. So in such cases, the traditional logic-based representations may not be sufficient. So we go for the probabilistic methods, fuzzy logic, or other uncertainty modeling techniques. Okay, and the few approaches what we have under this particular domain are is the probabilistic graphical model, fuzzy logic, possibility theory, evidence theory, neural networks, and possibilistic graphical model. Okay, so let us have an yeah, basic idea about each and every model. So let us see that probabilistic graphical model. So here the examples are the Bayesian networks and the Markov networks, which are widely used for representing and reasoning with uncertain knowledge. So the Bayesian network models probabilistic dependencies between the variables using directed acyclic graphs where the nodes represent the variables and the edges represent the probabilistic dependencies between the variable. And the Markov model, the probabilistic dependencies using undirected graphs where the nodes represent the variables and the edges represents the pairwise dependencies. So probabilistic graphical model allows for the efficient probabilistic inference, making them suitable for uncertain domains like the medical diagnosis, natural language processing, decision making under uncertainty. Where it comes to the fuzzy logic, it extends the classical logic to handle imprecise or vague information. So normally logic, it has only two levels, true or false. We don't have any values in between, like the digital logic, 0 or 1. 0 corresponds to false and 1 corresponds to true in a positive logic. But in the fuzzy logic, it allows the the fuzzy logic allows an user to choose any value between 0 and 1. Means the reasons may be partially true or partially false. It can be, again, this partial condition may be any value between 0 and 1. Say that is, yeah, any value between 0 to 100%. Either whatever the assumptions we make, that may be 10% true, 90% false, or in otherwise we have 90% true and 10% false. Like this, I can have any range of value sharing between 0 and 1. So that's why the fuzzy logic is much more adaptive in the cases of your uncertainties. So you might have seen many advertisement which shows in case of the washing machines. Mostly in the case of the washing machines, you have like the fuzzy logic based washing machine or the intelligent based washing machine, like that. It has been advertised, right? So you can see the fuzzy logic assigns membership functions to the variables, indicating the degree to which the an element belongs to a set. So it has a set of rules in which uses the linguistic variables and the fuzzy sets to represent the knowledge, enabling reasoning with imprecise or uncertain inputs. The fuzzy logic is applied in various domains, including control systems, pattern recognitions, and the expert systems. And it comes to the possibility theory. So it deals with the uncertainty by assigning the degrees of possibility to the statements rather than probabilities. Okay, and it allows for reasoning about uncertain knowledge based on the possibility of events rather than their likelihood. Okay, so the possibility theory is particularly useful in the situations where the precise probabilities are difficult to obtain or interpret. Okay, so for an example, you take a rolling of dice. Okay, the rolling of dice, for the probability for occurring any, I'll say the number one, right? The possibility of having number one in while rolling the dice, it is 1 by 6. Okay, that is the probability. But what is the possibility now if I roll a dice, if I to get a one, right? That there exists a difference between these two. Okay, if I am rolling a dice, what is the probability of getting a one? At this moment, if I roll a die by having certain logic or some trick, what is the possibility of getting a one? Okay, so this is what your possibility theory is. So there is no logic behind this. There is no exact mathematics which is going to map the happening here. But we are going to, since we are again we are going to consider there are certain conditions. Like you have in while the cricket match, while playing the cricket match during the last overs, we'll have like some people will say, if I watch the match, surely my supporting team will be failed. Okay, so what they will do? There is no direct relation between a person sitting and watching the match, and when he watches the match, the supporting team is getting failed. There is no direct logical connection or kind of thing. But based on certain recurrences, he may have the feel that he or she watches the cricket match, then the supporting team will be failed. Okay. Again, there is no logic behind this, but we have some possibilities that can be correlated. Okay, and the evidence theory, it provides a framework for reasoning with uncertain and the conflicting evidences. So it represents uncertainty using belief functions, which assign the degrees of beliefs to set of possible outcomes, and it allows combining the evidence from multiple sources and handling uncertainties or the conflicting information, right? So this scenario you can have it like from some investigation or some conspiracy stories, whatever you might have seen in series, right? Somewhere some while analyzing some case x or y, they would have arrived at some conclusion, and they will try to apply those conclusion here in the new case where it is nowhere related, but it may there may be a shadow of certain things, right? So that is your evidence based theory model. And the neural network, I hope you guys know that much more, you since you are many are aware about this neural network, which is the imitation of behavioral of an human, right, into the machine. Okay, so the neural networks perform the same way like how our brain works, but again it's not exactly, but in a domain specific way it is being developed. And these are particularly deep learning models can be used to learn complex mappings from the input data to the output predictions. And these neural networks can handle any uncertainty by providing the probabilistic outputs or by learning to represent the uncertainty in the internal representation. So the Bayesian neural networks, for example, it can provide a probabilistic framework for uncertainty estimation in deep learning models, and the possibilistic graphic models extends the traditional graphic model to handle the possibility distributions instead of the probability distribution. And they are particularly useful in the domains where the probability distributions are difficult to specify or interpret, such as the expert systems and decision support systems, right? And these are certain approaches which offers various way to represent and reason with uncertain knowledge, enabling the development of robust and effective systems in uncertain domains. The choice of representation depends on the specific characteristics of the problem domain and the nature of the uncertainty involved, and so the choice is ours here. We don't have any other, or we don't have anything new we are going to make it, or anything there is no strict guideline that you need to follow this model only, or we are going to adopt this model only, right? The choice of theory, whatever we follow, the choice of representation we want to follow is purely based on us, and also it depends on the computing capabilities of the machine. Wow, means what is the computation time? What is the time taken, time required for generating certain decision? What is the memory required to store the information? Right. See, the decisions under the uncertain conditions are derived based on the decisions what we take based on certain conditions with whatever the information we have. Okay, so in such a case, we should have a clear idea about it. Okay, thank you.